Hello everyone, welcome to AI Crack channel. This is Akash Gangwar and today we'll be studying functions lecture 2. So this is question 11 of the QOD series. Just take the screenshot for the same and let's start with the discussion. Now today we'll be discussing about types of functions. The first one are odd and even functions. So mathematically, when f of minus x equals to minus x, in that case the function is odd function. And similarly in case of f of minus x equals to fx, then the function is even function. So let's understand this with the help of few examples. Let's take fx equals to mod x. Now we know that this is an absolute function and anything which goes inside modulus becomes positive. So if we write f of minus x, that is nothing but mod x itself, right? So this is an example of even function. Let's take more examples. Let's say fx equals to ax square. Now in this case, if we write a times minus x square, a times minus x square, that is again ax square because of the square even power. So this is again an even function. Now talking about odd functions, let's say we have fx equals to ax, just ax, right? Now if we write f of minus x, then we'll have minus ax, which is minus of fx, right? So this is an example of odd function. Now I can see that whenever we are having odd powers in the function in the polynomial, then it's an odd function, and whenever we are having even power, then it's an even function. But if we write ax plus b, then even though its power is odd in this case, but still not an odd function. It's basically neither odd nor even, because if we write fx equals to ax plus b, then if we write f of minus x equals to a of minus x plus b, that becomes minus ax plus b. So this is neither minus fx nor fx, right? So that is why it's neither odd nor even. So there are basically three types of functions. One is even, one is odd, and the other one is neither odd nor even. So I took the example about this one. A function can neither be odd nor even. Let's take more examples. Let's say fx equals to e raised power x. Now in this case, if I write f of minus x, then we'll get e raised power minus x. Then we know that this is 1 by e raised power x. This is 1 by fx. So basically f of minus x equals to 1 by fx. So it doesn't satisfy our original definition of even function and neither odd function, right? So this is neither odd nor even. Now interesting point is there is just only one function which is both odd and even at the same time. That is fx equals to 0. So it remains 0 or minus 0. It can be, we can write it as 0 or minus 0. Both stays the same, right? So we can write it as minus fx, we can write it as fx. It stays the same. So that is why it's called both even and odd at the same time. Now let us understand the graphical methods of identifying odd and even functions. Let us look at the even functions first. Let's take an example, fx equals to mod x. Now we know that graph of mod x looks like this. So what does this say? Even functions are symmetric about y-axis. So this is our y-axis, this is our x-axis. Now we can assume that, imagine that we have a mirror over here. So we can see that this ray is just the reflection of this one, right? So this ray is the reflection of this one about the y-axis, about this mirror placed in y-axis. So this is called symmetric about y-axis, right? Similarly, we can plot fx equals to x square. That is also have the same situation. This particular curve is having mirror image about y-axis. If we place a mirror over here, then this curve is exactly opposite to this one, about this mirror. Now let's talk about odd functions. Odd functions are symmetric about origin. So what does that mean? Being symmetric about y-axis is kind of intuitive, but symmetric about origin is not that intuitive. Let's understand with the help of an example. Let's say we have a function called y equals to x cube. Now this looks like something like this, right? So this is our y-axis, this is our x-axis, this is our origin. Now symmetric about origin means if I go in this direction and travel a distance d, and if I go exactly opposite and I travel a distance d, then I'll find a point in this curve, and it will happen with every direction and every distance. So let's say if I take another distance d1 and I find a point here, and if I go exactly opposite in the same direction d2, then again I'll find one point. So if that is happening for all the directions and all the distances, then in that case this is called an odd function. This is called being symmetric about origin, right? Got the example? Now let's take one more example, y equals to sin x. So this is the graph of a sin x curve. This is pi, this is minus pi, and this is 0. Now if I go d distance over here and I'm finding a point, I'll go exactly opposite in this direction and I find a point. So if we do this for all distances in all directions, then we can see that y equals to sin x is an odd function. We can prove that as mathematically as well, right? If we write minus sin x, let's say fx equals to sin x, and f of minus x equals to sine of minus x. Then we studied in trigonometry that sine of minus x equals to minus sin x. So this is nothing but minus fx. So mathematically we can see that this is an odd function. We can also understand it intuitively with the help of symmetric about origin. Now let us try to understand one property of a function that says any function fx can be represented as a sum of odd and even function. So before explaining this property, I'll take few examples. Let's say we have fx plus f of minus x. Let's say this function is called gx. And if I try to write g of minus x, then I'll get f of minus x plus f of x, which is nothing but gx. So basically, this is an even function. G of x equals to g of minus x. This is an even function. Now let's take one more example. Let's say hx equals to f of x minus f of minus x. Now if I write h of minus x, we'll get f of minus x minus f of x. That is nothing but minus times fx minus f of minus x. This is minus hx, right? So we can see that difference one is an odd function. Now if I try to add hx plus gx, what will I get? I'll get 2fx. And if I write fx equals to hx plus gx by 2, then we get to understand the property of function fx. We get the same thing, right? Any function can be represented as a sum of odd and even function. So basically, if I want to write a function in terms of as a sum of odd and even function, what I'll have to do, I'll have to write in terms of this manner. So let's remove this and let's take one example. So let's take one example of fx equals to e raised power x. So basically f of minus x equals to e raised power minus x. Now if I try to write fx in terms of both these, so both of these, what I'll do, I'll write fx equals to e raised power x plus e raised power minus x divided by 2 plus e raised power x minus e raised power minus x divided by 2. So these are two functions, right? And we got to see that this one is an even function and this one is an odd function. So basically we wrote e raised power x as this one, summation of even and odd functions. So this is our property. Now let us look at one illustration. We have been given fx equals to ln x plus 1 plus x square. So this is the whole under root. Now the first step is to write f of minus x, right? ln minus x plus 1 plus x square. This stays the same because it's x square. So whenever I see something of this sort, a plus root b or a minus root b, then I tend to think about rationalization. So I'll do the same over here. So we have x plus under root 1 plus x square. And what I'll try to do, I'll try to rationalize it. So I'll do minus x plus 1 plus x square divided by minus x plus 1 plus x square. Now, if I multiply both of these, what I'll get? Minus x square plus 1 plus x square divided by minus x plus under root 1 plus x square. So this gets cancelled. So what is this? So basically, this is 1 by this. So this comes out to be 1 upon minus x plus under root 1 plus x square. So this is same as this, right? Now what we got, f of minus x equals to ln. I can write this as this raised to power minus 1, right? X plus 1 plus x square, this raised to power minus 1. Now we know the property of log that if we have something in power, it can get carried over here. So this is minus 1 into ln of x plus 1 plus x square. Now this is nothing but minus fx. So we got this as an odd function. So I'll try to summarize this once again because it got a little messy over here. So what I did, I did f of minus x over here, and we got minus x plus root of 1 plus x square. Now whenever I see something of this sort, a plus root b format, I try to rationalize it. So I rationalize it. Then what I got to know that this thing, this entire thing is nothing but 1 divided by this one. So basically I can write this as this raised to power minus 1. Minus 1 got carried over here because of the log property, and that is how f of minus x equals to minus fx. Now let us start different types of functions. The first one in line is polynomial functions, and the first one is linear function. So basically until now we have studied many theories about the functions, but now it's time to apply those theories in actual functions. So the first one is y equals to or fx equals to ax plus b. So this is the format for a linear function. This is the coefficient of x. This is the constant term. This is how it looks like. This is our fx equals to ax plus b. So this is our intercept b. So this is a very standard format. It can be over here as well, considering b is negative. But here we have assumed that it's positive. So we have taken b as here. So just memorize it as of now, because we'll be studying about linear functions, basically straight lines in coordinate geometry in entirely detailed manner. So as of now, just try to remember that this is a straight line. Most of us know already, but just for the information. Now let us first talk about the domain of this function. Now we can see that it can take integers, whole numbers, rational numbers, or irrational numbers, any real number. Basically, it can take any sort of real number. So basically, domain is x belongs to R. It can take any number. There is no restriction on the input. Now talking about the range, now we can see that if x increases, it goes up to infinity. If x decreases, it goes up to minus infinity. So again, range also belongs to R. Codomain actually depends on the definition of the function. If this function is defined from, let's say, R to R plus, let's say if this is defined like this, then in that case codomain would be R plus. But usually in linear functions, codomain is also R. So considering codomain is R, can we say that this is an onto function because range equals to codomain? So this is for this case, this is an onto function. It's not an into function, right? Now for talking about the 1 and many one function, can we say that this is a 1 function? Because if we draw a straight line over here, horizontal line over here, then we can see that it cuts just at one point, right? Now one might argue that, okay, let's say fx equals to, let's say, just b. So this is also a straight line, right? Because it goes like this. This is also a straight line. This is also linear. So this is a special case for linear functions. This is a constant function. As of now, we're talking about with a variable x. So once we have variable x over here, then we have to assume that it's slightly inclined and it's not a constant function. So in that case, it's a 1 function. Otherwise, for a constant function, it's not a 1 function. Now talking about odd function. So can we say that this is an odd function or even function? We cannot really be sure about it, right? Because let's say fx equals to just ax. In that case, this is an odd function because f of minus x would be minus ax. In that case, this is an odd function. But once we have written b over here, in that case, f of minus x equals to minus ax plus b. This is neither odd nor even. So we can never be really sure if this is going to be odd or even, or neither odd nor even. So it depends on the case basically. So we have got to understand all these properties for linear function. Now let us talk about quadratic function. So quadratic function looks like ax square plus bx plus c. This is the general equation for quadratic function. And this looks like the graph of quadratic function. So this is our lowest point. Let's assume this is, let's say this is point D over here. So this is our lowest point. Now we'll start again with the domain. Now we can see that it can take again any sort of value of x. It can be integers, it can be rational numbers, irrational numbers, fractional numbers, anything. It can take any number, right? So that is why x belongs to R. Now range is a little tricky over here. We can see that there is one minimum point over here. In this case where a is positive, this is upward facing parabola. In case a is negative, this is considering a is positive. This graph is considering a is positive. So we are talking about a is positive. In that case, range would be, let's say this value is, let's say e. So range would be e to infinity. We can see that it keeps on going up and up until infinity. If we put x equals to infinity over here, then we'll get fx equals to infinity, right? So range, upper end of range is infinity, lower range is e for d value, for x equals to d. This is for only for this case where a is greater than 0. In case a is less than 0, we'll have a curve like this. In that case, range would be, let's say this is f. In that case, range would be minus infinity to f, right? Now talking about if this is a 1-1 function or many-one function, so we can clearly see that this is a many-one function. It's cutting over here, it's cutting over here as well. So for two values of x, we are getting same value of y. So this is a many-one function. Now if it is an odd function or even function, so we cannot be sure if this is an even function or odd function. If it was a case that fx equals to just ax square, then we'll say that okay, this is an even function. It's symmetric about y-axis. But if it's given that ax square plus bx plus c, then we can never be sure that this is an even function or odd function, right? So not sure for odd and even. You might find this generalized for the case, for this cases just for ax square. Okay, we have assumed that fx equals to ax square only. In that case, many books might give that okay, ax square is even function, and similarly for linear graphs that ax y equals to ax equals to odd function. But usually we can never be sure, right? Now talking about onto and into function. So again, that depends on the codomain. Let's say we have defined codomain as here d to infinity, sorry, e to infinity. In that case, this is an onto function, right? So I think we have discussed all the properties of quadratic functions. We'll again talk about more technicalities and more problems about quadratic functions during the quadratic equation chapter. But as of now, you have to just understand these properties: domain, range, codomain, many-one, onto, into, that kind of thing. Now let us quickly discuss about cubic and biquadratic functions. As the name suggests, cubic, it should have 3 degrees. So basically, fx equals to ax cube plus bx square plus cx plus d. Now we can safely assume that in any case or in any cubic equation or cubic function, we can have maximum of 3 real roots, right? Similarly, in case of quadratic equation, we can have maximum of 2 real roots. In case of linear equation, we can have maximum of 1 real root. Now, what is the significance of this one? Why I'm talking about this? Because graph of a cubic equation looks like this. So it's cutting at 3 points. Usually, I'm not saying always, usually it cuts at 3 points in case of real roots. So let's quickly discuss the domain, range, codomain, onto, into, many one function, odd even functions, all these things for cubic functions. We'll talk about the basic case. So domain should be R. As simple as that. We can take any value of x, rational, irrational, any value of x. So domain belongs to R. Now talking about range, then we can see that it goes from minus infinity to infinity, because if we keep x as positive infinity, we'll get fx as infinity. If we keep x as minus infinity, we'll get again minus infinity. So we can see that range is minus infinity to infinity. Basically range belongs to R. Now talking about codomain, let's say this is also R. Let's say we are defining codomain as R. We are defining function from R to R. Now if it's one or many one, so for with the help of a horizontal line test, we can clearly say that this is a many one function. Mostly, just for one case, except one case. What is that case? Fx equals to ax cube. In that case, the function looks like this. So it's cutting at just 1 point over here. So all these points are just 1 points. So in case of this kind of cubic equation, we can say that this is a many one. This is a one function. Other than this case, this particular case, all the cubic equations or cubic functions are many one functions. Now talking about odd and even. So again, that boils down to if fx equals to x cube, then it's odd. If it looks like this, then neither odd nor even. We cannot say anything. So just for this one, it's odd. And for rest of the equation, for the general equation, it's neither odd nor even. Now talking about onto into, in this case, codomain equals to range. So basically it's an onto function, because range is also R. Codomain is also being defined as R. In that case, codomain equals to range. So this is an onto function for this one. Now let's quickly understand biquadratic function. So for biquadratic function, we have, as the name suggests, it should have degree 4. So ax4 plus bx cube plus cx square plus dx plus e. Now it should have 4 roots, maximum of 4 real roots. So what should be the graph look like generally? So it's cutting at here, it's cutting at here, here and here. So these are the 4 roots, and we can clearly see that it is going only up. It's not going till minus infinity because of the even power, right? So domain equals to R, same as linear, quadratic, cubic, and for this one as well, domain belongs to R. Now talking about codomain, let's take it as R as well. Now talking about range. So range is, we have a minimum value over here. We have certain minimum value over here. Let's call it as, let's say E, not E, let's call it as F. So this is F to infinity. So we can see that if codomain is R and range is F to infinity, in that case, this is an onto function, sorry, into function. Now, if this is one or many one, this is clearly many one. If we make a horizontal line over here, we do the horizontal line test, then we can see that it is cutting horizontally at multiple points. So this is a many one function. Now talking about if this is an odd function or even function, then again it depends on the cases. If only ax4, then even. If the generic equation is there, then neither odd nor even, right? So this was a discussion about cubic and biquadratic equations or functions. So the contents of this slide I've already discussed, right? Odd degree polynomials have range from minus infinity to infinity. We have seen that in case of a linear function or a cubic function, we can see that the range is from minus infinity to infinity, basically R. But in case of even degree, it's not equals to R, because it's from certain value, let's say E to infinity or minus infinity to F. That is the case in case of even degree polynomials. We have seen that in quadratic and biquadratic as well. Now let us talk about modulus function. So this is our y-axis, this is our x-axis. So fx equals to mod x. Now let's discuss the properties of this function. Now we know that anything which goes inside modulus becomes positive. That's why it's never in the negative zone. It's always either 0 or greater than 0. So we can clearly see that x can be anything. It can be rational number, irrational number, fraction part, integer, anything. So domain belongs to R. There are no restrictions. Now if we talk about the range is clearly, range for this function, for modulus, just modulus x, range is clearly 0 to infinity. 0 is included, that is square bracket. Now if we talk about codomain, let's say codomain is also 0 to infinity. If this is codomain, then this is an onto function, right? Now talking about many one. So this is clearly a many one function. In every case, this is a many one function. So this is a many one function. Now what is left, odd or even? So for just this function, we have not talked about mod x plus something. We are not talking about that. We're just talking about mod x. In that case, this is symmetric about y-axis. We can clearly see that these two lines are mirror images of each other. So that is why this is an even function. We can also put f of minus x equals to mod of minus x, which is nothing but mod x. So we can see this algebraically as well, that this is an even function. It's not an odd function. So now once we are done with all the properties of all the functions, as of now we have just covered 2 functions. After that we'll be covering few more functions in the next lecture. So once we are done with all the properties of these functions, basic properties, we'll go into more technicalities of individual function. So we'll talk more about quadratic functions, how roots are being defined, what are the different cases for the roots, equal roots, different roots, discriminants, all these things we'll be talking about in more detail once we're done with the basic properties. So today's lecture is still here only. So from tomorrow's lecture, we'll be studying few more functions, and after that, we'll be studying all these functions in more detail. And once this video is being uploaded on YouTube, material related to this one will be provided in the PrepMaster portal. You can download it, you can watch it, you can solve it. All right, then let's meet tomorrow. Thanks for watching.